All right, so finally, let's go back and show you the monstrosity that is the core, okay? So now inside of the core, the boundary is going to look very, very horrible, right? It's going to look like this, okay? So now this is a boundary that is parameterized with a bunch of things because I don't have a case class for invoices because inside of the invoice, I would need to have an option. And I'm not allowed to use option because options is inside of the standard library. And therefore, I needed to be able to inject something into the invoice, some magical maybe type, okay? And therefore, I couldn't even create a case class over here. Right. I'm not saying that I would never be allowed to do this, but I can also, another reason why I can't generate a case class because inside of this invoice is going to be something like when it was created. It's a local date, but I don't have a local date, so I need the ability to inject this. Okay, so this is the boundary. Okay, I still have the year, which is int. Remember, I'm allowed to use the primitive types. This is the first invoice number, which is int. I'm allowed to use the primitive types. Double, I'm allowed to use double. Okay, but for the rate, I needed some form of maybe, right? I'm not allowed to use option. Okay, and then I needed a collection. Okay, so I called it multiple invoices, and inside of it is going to be invoice. Okay, extremely abstract code. Now the implementation. Remember, we went from like just one dependency, right? So just give me like the gate. We went to this monstrosity, which is like a bunch of parameters, a bunch of context bounds, also other things that I didn't want to use context bounds for. I'm also using some functions over here. For example, the standard library, it knows how to convert like ranges into some other collection. Over here, I didn't have this fancy ability, so I needed to insert an implicit conversion. Well, in fact, it doesn't need to be implicit now that I'm thinking about it, but that's not the point. I needed to inject a function that would be able to do this. The last day of month is again a function that just can like out of thin air summon like the last day of the month. And so in the end, I'm constructing the boundary with multiple invoices, which is going to be the collection with the maybe, and then it's going to be an invoice, and inside of it is going to be a maybe, which is why the invoice has this weird type, right? So invoice, and inside of it, it needs to be a type over a higher kind, right? So maybe is a type over a higher kind over here. One of the like sort of like beauties of this code is, because it's not all ugly, is that the code itself pretty much looks almost exactly the same as before, right? So I still have like generate invoices. I have to like myself create like range, right? So I do like range.make. I shadowed the name range. So this is not the Scala range. This is my range. I can jump in there and you'll see that this is just a a summoner and some type over here. Okay, but we'll go through this in a bit. Okay, I'm creating a range. I'm doing the same fold. I'm creating a tuple 2 inside of it. I'm creating some collection with an I of maybe, and it's going to be empty. There's the first invoice number. I cannot pattern match on this tuple over here, so now I need to do this. And by the way, remember that this tuple is not the one from the standard library. So I created functions that are called the same way, right? The methods that are called the same way. So we have like _1, we have like _2. Okay, new invoice is the same way. I'm doing like invoices, which is the type of invoices is multiple invoices of I of maybe. It's not some standard library vector or something like this. Creating another collection, yada yada yada. Okay, so a couple of things that I want to show you over here is like all of these like private devs, they're very, very similar. They just like have these types. Is like this monstrosity. Okay, so I cannot have a case class for an invoice, and therefore this is going to be my invoice. It's going to be a trait. By the way, it's called invoice. I used to in the beginning when I came up with it, I call it make invoice, right? But then I changed it so that it kind of looks more beautiful. So whenever I'm creating an invoice, I'm doing like invoice.make. Okay. By the way, most of the types are actually inferred. So the type inference was actually not the issue, which I found surprising actually. It got a little bit better in Scala 3. This is the actual invoice with some weird type inside, right? So it's going to be invoice of option of double, right? And this is going to be the local date, and this is going to be the option. Okay, so created on is going to be some date. Amount is going to be some maybe of double, and therefore I have an invoice of a maybe. Okay, and this is the summoner, which looks kind of ugly. So yeah. Okay, so this is the invoice. Okay, so this is the boundary, and let's go through the type class a little bit and kind of like sort of like the purpose of effect tracking, but remember, effect tracking was not the purpose of this video, it just kind of happened. Also, I kind of found that people often throw around the term tagless final. I have an entire playlist about it. You might want to check it out. And there's a difference between tagless final and just using type classes. In this particular case, it actually ended up accidentally being tagless final, because for tagless final, your algebra, all of the methods in your algebra need to return this parametric type. Like usually there would be like only one type. Okay, so if you have some trait algebra, oh my god, algebra, and you have some type over there, right? Then if you have depths inside of them, right, M1, M2, and M3, if you want this to be a tagless final, then the A should be somehow in the return type of all of them, right? Then it's proper tagless final. Usually, it's the F, it's a parametric one because usually we want to abstract the effect type, right? And then you would return an F of, I don't know, this one will return an F of unit, and this one will return an F of int or something like this, right? And this one would return like an F of double. So if all of your functions return this parametric type, then it's tagless final. Otherwise, well, you're just using type classes. And also, by the way, usually when people use type classes, they want them to have only one instance, and also they want them to have some laws. Now, I'm not that pedantic. This was not the purpose of this whole thing. I just created type classes that don't have any laws. Basically, anytime I needed to call something on the standard library or in some other library, I was forced to create a thing that would do this for me, right? So for example, on a date, I'm constructing the date, which is why you see like date over here, and I'm adding like plus month, and these are like the only things that I'm doing with dates. Well, there's a caveat to that because I'm also like getting like the last day of the month, but it's kind of like outside of this whole thing. Okay, so there's some certain like beauty to this, and it's the fact that if you look at these types, you can pretty much smell the implementation, so you don't need to look at the implementation. Obviously, there are many caveats to this. There's always like null, there's always like throwing the exception. Also, even though the types are so strict, there can still be multiple implementations, right? It's just that the number of the implementations is very much constrained. And by the way, I have another video about this called the Curry-Howard-Lombok isomorphism. You might want to check it out. I'm talking about this over there, okay? So for example, you can see which things am I creating here. Okay, I see over here that I'm going to create the date. I'm not going to create the invoice. Well, actually, I will. You just don't see it here. I will create it because of this thing, okay? I'm not going to create a maybe, but I'm going to map, right? This means that maybe has to come from somewhere, right? So you kind of see, okay, oh, so the rate is going to come in, and the only thing that I'm going to be able to do with it is going to be map. And therefore, I'm going to probably map this rate to invoices. Oh, and therefore, this is why inside of the invoice, I actually have a maybe, right, over here, right? So inside of the invoice, I actually have a maybe. Okay, so you kind of smell those things. So you see that there will be like two different collections. Like the implementation might inject the same one. And in fact, this is what I did. I injected the vector because I was too lazy to implement the type classes for multiple collections. But that's not the point. It could be two different ones. With one of them, I'm doing like map filter lengths first and last. With another one, I'm actually creating it, right? And I'm concatenating it. Okay, so you have like a lot of information that comes from these types. Then we have the R, which is going to be a range. So I'm going to be able to construct the range, and I'm going to be able to do a fold left. By the way, the range is not like a typical collection. It's not parameterized with a type. It's always a range of int. And therefore, this fold left is a little bit specific, right? So inside of this fold left, it's hard-coded to be an integer over here, okay? So, yeah, and then the tuples. I'm creating the tuples, I'm getting the first element, I'm getting the second element, okay? Now, I still have the gate, which is like my one dependency, and a couple of other things. But again, the beauty of it is kind of that the actual code hasn't actually changed much. For example, let's go and look at generate first invoice number, right? So if you compare this to BCD, that's not D. Hold on, which one were we in? Oh, we were accidentally in B. I actually wanted to be in A, okay? But the A is pretty much the same, okay? So this is the A. It looks exactly the same. I'll show you the difference in just a second. We didn't get to the part with the difference, okay? So this is A, B, C, D, okay? So compare something like boundary generate first invoice of months, okay? So where we use the standard library, it looks like this. Where we don't use the standard library, it looks like, okay, now I need to find it over here as well, first invoice. Okay, so let's actually do like this and like that. And is it the last one? Yes, it's the last one. So let's go here and do like that and like that. It's going to be like in the middle of the screen, so it's going to be at the same level, okay? So look, it's like 3 lines that do something generating the invoice. Okay, so over here, the same thing, 3 lines that do something generating the invoice, okay? So even though we're doing like something very, very abstract, the implementation is pretty much the same. I also feel compelled to show you the second boundary because over there I did the same thing, right? Remember, I needed to implement is work day and I couldn't do it because I didn't have the local date. So I ended up implementing like these types, right? So like I need date and I need a day, and for day, I need to have, equality, and I need to have the ability to get like Saturday, and I need to the ability to get Sunday. okay? And therefore, like I have a date and I have like a day of week, and I do like same as, like this is my equality. Scala 3 has a built-in type class for equality, but I didn't want to use it because it's in the standard library, okay? And then I'm doing like setID.make, and again, like setID is my thing, okay? It's just a trait over here that has a method make. Yeah, so you kind of have like these two boundaries. Let me show you the tests, okay? So we need to go to the boundary suite. The tests look pretty much exactly the same, right? So they also use like this make thing, like all the tests are the same. It's just that the actual function to do like the make looks very different. First of all, I needed to generate a given instance for what I consider to be an invoice. And because I don't have a case class for invoices, I actually had the ability to create a different case class that would have only that field that I'm actually testing. Remember, like in all of my tests, I'm actually only using the work hours. So it was enough to have a case class that only has the work hours. And so I needed to implement the instance for my type class of invoices that would have like this function make, where I'm ignoring everything and I'm using only the work hours. And also notice that my invoice case class does not have any parameters. And so I needed to do like this hack so that it just has the same kind, so that I can generate the same instance over here. Now, the make looks horrendous because I'm being forced to specify all of these types. Now, I don't need to specify these types, okay? So if I remove this, like this is still fine, okay? The type over here is still infers to, you know, really beautiful types. It's still a boundary of a vector of option and of I of option, okay? If I go back, it's exactly the same thing, okay? By the way, it actually could be, I believe, that I could do invoice case class over here. Probably not. Probably I cannot do this. Okay. I can. Yeah, I can. Okay. But that's not the point. The point is that over here I cannot leave out these types. Okay. So if I do this, it's not going to compile. Okay. But if I actually remove them, right, then you see that it still kind of has like only one dependency because everything else is implicit, right? So basically I'm specifying that my D is going to be the local date, my invoice is going to be I, my maybe is going to be option, my first collection, which is like multiple invoices, is going to be a vector. The second collection, which is multiple dates, is also going to be a vector. Then my real range is going to be Scala range because I have the instances for Scala range and I have the tuples. So this is pretty much the boundary. Because of this, like the gate also needs to have this type parameter, but that's like the only difference. And the use case 2 I have already shown you. Okay, so again, like at the top I only have like the type classes. Okay, so basically I created a file, I called it type classes, I threw in like a bunch of traits. Okay, so these are all the type classes that I needed. I didn't bother to call something like map a functor because this is not the purpose of this video. Again, the code of this is on GitHub. Check out the description below for the link, and you're gonna have access to this whole thing. Okay, so another thing that I have over here in type classes is my test suite, right, which is just a helper to write all the tests. And I needed it to be at the very top. I kind of made an exception. I was like, okay, I'm going to use this. It's fine. Okay. And so the core has a dependency on type classes, and therefore over here in the boundary suite, I can do extends test suite. Okay. So at the very top, I'm doing extends test suite. Okay. And by the way, it runs, it's all, you know, it all works exactly the same way, right? So it takes the same amount of time to run and blah, blah, blah. So the other thing on the level 1 is the third-party dependencies, okay, which is like these type class instances, right? And in Scala 3, it's very simple to declare the instances, and also the implementations of them are super straightforward. They just delegate into the real types, okay? So plus months for local date is actually going to call plus months, okay? So all of them are really simple. Let me actually scroll through them. There's nothing, it's just like boilerplate. All of this stuff is boilerplate, except for maybe this one, right? And yeah, and like this is the thing that I meant. For example, if I wanted to change the signature of this one, right? This whole thing, right? So this trait, last day of months, would change because it's not int to int anymore. It's int to some abstract D. Okay, and therefore the instance would also need to change, and therefore, you know, the boundary, the first one, would also needed to be changed, because I would not have like this last day of months thing. I will have just like a function, like somewhere to, you know, that will be able to like out of thin air to create a last day of the month and so on. Because again, like this looks a little bit weird. Let me show this to you. This one, see? No, not this one. This one. We say make dates in order, we give it the year months, and we calculate the last day of months, and we're using the year months again, right? So it feels like there should be one function that just gives it to you. Let's go and look at the other things, okay? So for example, the config, well, the config didn't really change much, okay? So over here, the config implementation is the same. The core self, same. the terminal, something's changing there because I actually needed to go down and I actually needed to define this invoice case class. It's sort of like redefining, like I have it in the test, I have a slightly different version over here, okay? But apart from that, not much has changed, okay? I have to specify the types over here. I have to say like which kind of boundary I want. But apart from it, like everything stayed the same, okay? Let's look at the dependency injection. Now the dependency injection for the second use case, same. The one for the first use case is slightly more involved. Same as in the test, I had to do this hack and I had to generate like this instance for, for different case class now. I had to specify all of these types the same as I do in the tests. But apart from that, everything is fine, right? And obviously I need to have like all of these instances and I actually haven't show you, well, I have shown you the instances, but what I do with my packages is that like all of the instances are in this package, right? So it's a very like global package, and therefore I don't need to import them. Okay, and yeah, and so the main is now looks exactly the same. Now let's continue to B. Okay, so in B, what I realized was that for the second use case, I didn't want to abstract it away. I kind of felt like if this was like done in a team, then people would use like every escape hatch possible to actually implement it. Okay, so the use case 2 now has its own gate. So whereas in the version A over here, I actually had the implementation, right? So let me actually open it, boundary 2. So this was the boundary 2 in the version A. I had actually the implementation. I had all of these type classes. Over here, I decided, you know what? I'm just going to let the gate implement it. And the gate will have the standard library to implement it. Okay, so over here in core self, I actually have the use case 2 in gate. And over there, I'm actually implementing it with, just by using the regular standard library. And therefore, in the dependency injection for the second use case, I inject this gate. Okay, and so this is the boundary for a local date. And by the way, if you have seen my video about bat and delta, you can actually use something like delta to show you the diff. So for example, if I open the terminal over here, and by the way, again, it runs the same way as before. Okay, so if I just create a little bit more space, okay, so let me like get out of here and I can do something like delta. Okay, and I'm gonna go into A and I'm gonna go into 0, 1 core. Right, so as you can see, I've already been practicing. Okay, so don't just compare A and B because I don't know how to teach Delta to ignore a bunch of files. Well, I don't remember. Okay, so just compare like the source, right? So for example, like this, and you're gonna see like this is basically the difference now. Okay, so in the boundary for the use case 2, I now don't need all of these type classes because I'm not doing the implementation. Okay, the implementation is going to be somewhere else. Okay, and therefore I need the gate. Okay, and so we can do the same thing for 0 to B core self, right? So comparing the core self, okay? So now because of this, I need to have the gate implementation. Okay, so this is pretty much the only difference. Okay, we can also do with the 3 main source like this. Okay, so in the dependency graph, this is the part that changed, right? So now in order to construct this boundary, I actually need to inject the gate. Okay, cool. Now let's progress to the third version. Now the third version, and by the way, because of this, I needed last type classes, right? So like these, we scroll up. I don't see it anymore. Hold on. No, the core. I want the core. Okay, because I did not need these type classes. Like I had to, I could remove them, and I could remove the instances for them as well. Okay, so let's go to the third one. And the third one is the one where I allowed myself to use everything from the standard library except for the local date. The dependency graph looks exactly the same. Okay, however, if I go to core now, to the boundary, okay, you're going to see that it's much less pleasant to look at. Okay, I still need to abstract like the notion of the invoice because inside of it, I still need the local date, right? So I was kind of forced to still abstract it away. But apart from this, okay, there's a parameter and, for the dates, and I need to be able to construct it. I need to be able to do plus month. I need to be able to do like last day of the month. So it's a little bit less, okay? And also my invoice itself, it does not look like as scary as it used to be because it doesn't have this higher kind of type inside of there, right? So it's just like a normal type here, normal type here. There are no like, no weird underscores, okay? So my invoice type became more simple. Therefore, my tests became, a little bit more simple, right? So dependency injection over here, right? So I'm just specifying, okay, I'm actually talking about local date, and I'm still going to, still abstracted away the invoice case class. Okay, so this looks like much more pleasant, and because of this, like over here, I'm actually still using the gate, but it's actually, no, I still need to use the gate because, well, The thing is that I did it in such a way that I had this monstrous version, the version A, and then I did the B by making it simpler, and then I did this one, C, to making it simpler, so I still have the gate over here, and then I made the D where I did like the normal one, okay? Let's see. Is there anything that is valuable to show here? I don't think so. Yeah, probably this one, right? So I still need this given instance, but at least I don't need to have this weird type alias. Remember, over here, and the DI for the first one, not this one, DI for the first one. Remember, I needed to have like this type alias just so that the kinds match. Over here, I don't need it anymore. Okay, so I can just have this invoice. Am I in the right one? I am, but I thought I was in the. I thought I was in DI. Where's DI for one? No, this is D. I wanted to be here. Yeah, exactly. DI for the one, right? So it looks like much more simple. Just two type parameters. Was my case class. The implementation is much simpler. And again, over here, we can do some like delta B and compare it with C. Okay, so I need to go up first like this. Okay, so you'll see that, just like less types. Okay, so this is how you can like go about discovering this repository for you. Okay, and then we have D in the end, right, which is the one that has like everything is very, very simple. There are no type parameters, nothing weird. I've already shown it to you. This is the boundary, no type parameters, no nothing, just one dependency. Very beautiful, and this is how you should develop the production level applications. All the other stuff was just an experiment. All right, so it's on GitHub. Go check it out, and I see you in the next one. For now, as always, it's been Vlad from devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. Please consider supporting me on GitHub sponsors or Patreon, whichever you prefer, and let's watch my videos weeks and sometimes even months before everyone else. Most importantly, take care.